Hello, everyone. Welcome to the second developer community meeting for AI. Today, we're going to be going over the Titanic competition on Kaggle, and then we're going to be looking at how to deploy a model. Right. So, links, and let me go over here to the actual competition. So here it is. I can send this in the chat. This is a Titanic competition. It's gonna have something like you read the rules and you want to join. That's how you join, and you get the chance to make your own notebook to submit. So going over what this competition is about, it's about predicting whether a passenger on the Titanic survives the wreck or not, based on some data like their name, age, gender, socioeconomic status, how much they paid to get on the cruise ship. And this is also considered one of the Hello World type competitions here on Kaggle. So there's a lot of helpful resources in the discussion for you. So let's go on to the evaluation. So here they restate the goal. It's to predict if a passenger survived the sinking of the Titanic or not. And for each test set, you must predict a 0 or 1 for the variable. So this is called binary classification, meaning it can either be 0 or 1. The metric, this is what you're going to be using to improve your model. And what they want here is accuracy. In other competitions, if they're talking about something like regression, this might be like mean squared error or root mean squared error. And it also has a submission file format where it's going to be a data frame with 2 columns. One column is the passenger ID, and another column is whether they survived or not. So let's go over data. There's 2 data sets that they give you right away, a training set and a test set. Usually in competitions, they'll always give you some sort of training set. And in some competitions, they don't give you a test set, but some do. So what's in the training set? So there's a couple of variables. You got survival. This is the answer that's given in the training set. This is not in the test set, but it's in the training set. The P class, which is the ticket class. The sex, either male or female. Age, sib SP, which is number of siblings. P arch, number of parents. Ticket, the ticket number. Fare, the passenger fare, this is how much they paid. A cabin, the cabin number. Embarked, the port of embarkation. And there's 3 options here. And there's also some notes they have here. Right. And right off the bat, you can actually submit the sample submission they gave you, gender submission. And this has, since only 70% of females survived and the rest were male, it's going to be pretty accurate, about 70% accurate, but we can make that more accurate, as you'll see now. Let me show the leaderboard real quick. And let me say this right away. In the last developer community meeting, I said that there were cheaters on Kaggle. Well, these people up here at the top with scores of 100% accuracy, yeah, these are all cheaters. This is a very old competition. And for beginners, it's been solved dozens upon dozens upon dozens of times. So the data set with like the correct answers is already out there. So don't be discouraged if you see all these people with 100% accuracy scores. These are cheaters. Don't worry about it. Right. So let's go into the notebook I made for this, or the notebook I kind of stole. Not gonna lie. I put my source though here. Let me share it with you guys. And I'll put it in the chat. How do they even cheat? They get the data set with all the correct answers off the internet and they just submit that. It is what it is, man. Cheaters on the internet, you're gonna find them everywhere. Right. So quick introduction. Let's go over what we saw in the main page of the competition. The goal is a binary classification of whether a passenger survived or not. The evaluation metric that they're looking for is accuracy. The submission file format is 2 columns, the passenger ID and their survival. It's either 0 or 1, whether they survived or not. And some relevant rules are there's 10 members max per team, no sharing private notebooks outside of Kaggle. This is kind of a given. 10 members per team, that's kind of a lot, but I mean, if you have a lot of friends, go ahead. Here's some libraries that we're going to be using: Pandas, NumPy, Seaborn, and Matplotlib. These are just for graphs, so don't worry about them. And Re, this is for regular expressions. I'll explain what these are later. So now we can import our train and test sets. As I mentioned before, the data for the competition is up here in input. And output, that's where we're going to be outputting our answers. So Titanic, it has this stuff. And using the read CSV, you can get the file path over here and copy and paste it over here. Right. So getting a quick look at what's in these sets, data sets. Well, the training set has 12 columns and the test set has 11 columns. This is what I was saying before. The survived column, which has the answers, is not in the test set because that's what you need to predict and submit as your answers. There's a couple integers, objects. This can be string data or some type of data structure like a list, but in this case, it's string data. You can do describe. This is a very useful function in Pandas to get a couple of common statistics when it comes to numerical data in your data frame. So for example, I wouldn't look at passenger ID survive because this is arbitrary and this is either 0 or 1. So I would look more to age, P class, because these are not arbitrary values. As you can see, 0.42 in age, this means that it's like a fraction of the age, so it's like a baby. And the max, 80. That's some pretty old dudes. All right. So the person I copied this from did this like this, but you can actually just do this instead without the print statement. Let me run this stuff. It's going to take a while to. Any questions in the meantime? Yeah. You usually want to use the pandas, the methods already in pandas, because you don't want to import new libraries and stuff when pandas already does it for you. All right, so here's the data. df train.head. As you can see, it's a lot prettier now. It's in this table format, like an Excel sheet. You can see your passenger ID, survived, this is the answers, your P class, your passenger class, name, sex, age, blah, 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 blah. So we can start exploring the data as well. Here we're getting the top 5 rows. And as you can see, the first thing this guy did, he looked at the name and saw that there were titles like Mr., Mrs., Miss. So he using a regular expression, which is a general expression to get a string from a string, you can get the title for each of these rows. So let me explain this right here. It's getting the capital letter and a lowercase letter. So capital M, R, and it can be more than one lowercase letter because of this plus, and then it ends with a period. And this forward slash here is just an escape character. Like, you know how in C it's escape character N, this is a new line. Escape character period, this is a period. So we're looking for a capital letter, a lowercase letter, and a period. Lowercase letter or more than one. So since there's 3 lowercase letters here, it gets all of them. It's very useful. As you can see, he basically got all the titles for every name. And you can, after that, you can basically just drop the entire name column, because this is a pretty bad column for training a model. It can introduce a lot of bias. Right, so here it is. There's a lot of titles. Mr., Mrs., Miss, Master, Don. I didn't know some mafia bosses were in the Titanic, but apparently there are. Reverend, Doctor, MME, I don't know what that is. Miss, Major, Lady, Sir, Mill, Colonel, Captain, Countess, John Keir. So you can basically make a new column that's just titles. So title, like that. Oops. So now you have a title, and you can drop this name column now. Question?
I got a question, David.
Yeah.
I seen in the lambda function you use re. Where is that from? Oh, my bad.
Re, this is the regex library that we imported.
Oh, okay. Do you mind explaining quickly that lambda function? Like, what are we doing with that?
Right. So let me explain what the entire thing is. All right. DF test, you're passing in, so you're using the test data frame. You're going to the name column, which is this one. Apply. This is, you're applying a function to all the rows in the column. And this lambda function, this is an inline function. So this is the function you're applying to the entire column. So what you're doing is searching in this, for every row, you're searching for that title. And you're basically going to return that title. So you're going to be making a new column, and for every row, it's going to be looking for a title and putting it in that new column. So for here, Brown, Mr. Owen Harris, it will look for Mr. and put it in the title.
Okay, I see that. Thanks.
Any other questions? All right. So now he's going to simplify it here. Captain, Colonel, Major, Doctor, Reverend, these are officer titles. John Keir, Don, Sir, Countess, Donna, Lady, those are royalty titles. MME, that's a Mrs. apparently. MS, that's also a Mrs. Mrs, that's of course a Mrs. MLE, Miss, Mr, Master. This is just to simplify it because you don't want too much of a variety, especially when there's only like one John here and one Don, because that introduces bias. And bias is basically just putting value to features that are don't have much variety. Right. And here's the titles grouped. This after changing it to the more general titles. And he also printed out the rate of survival for each title. And apparently, as you can see, the female titles survive more. All right, and now he goes on to handling the age variable. He's basically trying to find the distribution of who died and who survived. And it's kind of a normal distribution. It's pretty normal. Uniform, I mean. And now he's trying to deal with the what's it called? The Nand values. And the Nand values are basically, there's no data for for those values. So he's getting the median for every title, and he's going to try and see, like, okay, for this person who doesn't have an age, their title, let's say it's Mrs. For a Mrs. that doesn't have an age, we should give it the value of 40 instead of a null value. And that's how he's trying to solve it. If you don't, if you don't want to deal it like this, another option is to just put an arbitrary value, but that's not recommended. And another way to deal with Nand values is to just delete the column or row that has a ton of Nand values, but that's also not recommended because you're narrowing down your data. Why I use the median instead of the mean? The mean is subject to let me not use that anymore. Well, the mean is subject to having influence from high values or low values. So let's say we have 5 misters, and one of them or 4 of them are like in their 20s, and one of them is 80 years old. The mean of that would be probably in the 50s because of the one that's 80s, the one that's 80. But for the median, it would be 20. So that's why. That's why we use median. And median is just a more reliable than mean overall. So now he's imputing the values. And imputing is a statistical term. It just means replacing the Nand values. So he's locating all the places where the age is null or Nand, and he's going to replace it with the median. Right. And now here he's going to plot it out. It's pretty normal. This is some good data, not gonna lie. And here he's just separating by the people that didn't survive and the people that did survive. And as you can see, the people that didn't survive, they're usually in their early 20s or late 20s, just in their 20s. And now he's going to separate the different age ranges by babies, children, teen, student, young, adult, and senior. He did, I don't like the way he did this. He basically did a couple intervals, like this is like a percent of the data, like the lower percent of the data, 0 to 5% from the middle, 12 to 18, 25 to 30, 35 and 35 to 60, 160 to 120. I don't like this way. It would have been better to just have like different age ranges for each one, but I guess this is how he did it. And he also put a little bit too many categories, to be honest. Like, what's the difference between student and young? I don't understand, but it is what it is. And you always do what you do to the training set, you always do to the test set as well. Because if you don't, it's going to be different when it comes time to predict, and it's going to be a headache. Usually what people do is that they combine the training and test sets, and they do all the changes with the combined data set, and then they separate it again. But this guy's doing it separate. And now he's using a pandas wrapper for a matplotlib function called Crosstab it's basically like a box chart, and he's showing the people that didn't survive and survived based on their ages, on the age categories that he just made. Like I said, you probably want to be using the built-in pandas functions and not doing with MATLAB or matplotlib, because the pandas functions usually go over the entire data set more quickly. So now he's going to see the average fare per age group, and it turns out that babies have the highest value in fare. So it was pretty funny. Now he's looking at the fare distribution. And fare, this is just the amount of money that people paid to go on the Titanic. Some more data. And now he's going to do the same thing he did for age, but for fare. He's going to split up the different sections of the distribution into different amounts. And here's the survival rate of each amount. So port 1 is like the poor people, the cheap is like a little bit more expensive, a lot more expensive, and a lot more expensive, the most expensive. So these people spent the most. And as you can see, they kind of survived more as well. But that's because there were more people as well in this quarter. Right. So we do it in the test set as well. And now he's deleting all the columns that we don't need anymore, like name, cabin. We could have done something with cabin, like lower deck, higher deck, and middle deck, but I guess he didn't do it. Fair, ticket, those are not, we're not using that anymore. Well, ticket in particular, this is an arbitrary value. What that means is it doesn't really matter what the ticket number is. It's like phone number. Everyone has a unique phone number, so it doesn't really matter. You're not gonna the number on your ticket or your phone number isn't gonna determine whether you survived the Titanic or not. And it looks pretty neat right now. So now he's looking at who survived or not based on the passenger ID. Looks normal. 500 to 342. That's about 70%. And he's doing the distribution. This is the same pandas wrapper Crosstab. And he's doing the distribution of who survived or not based on their sex, male or female. As you can see, female, a lot more survived because, you know, women and children first on the lifeboats. Did I do this one? Now he's doing the same with, well, not the same. He's doing a passenger class over embarked. He changed the names of the ports with, oh wait, never mind. Oh wait, he did with C, Q, and S. So S is, I forgot what it was, to be honest. It was Southampton, Q is Queenstown, and C is Cherbourg. And there's a couple of Nand values in the embarked column as well. So he filled it with S, which is the most common one. And now he's doing it by the passenger class, seeing who survived or not. Or were they embarked, I guess. There's a lot of graphs, and this is just to get an overall feel of what the data looks like. Because from these graphs, you can also determine what type of model you need to use. If you see that things aren't lining up, you probably can't use a linear model. But in this case, we can. And it's already 6:34, so I'm gonna try to speed it up a bit. He's just going over the rest of the data for the SIB, for the number of siblings and number of parents. He basically combines it into family count or family size and puts it as a new column. Let me actually run these just in case. It's just reducing the amount of features that we have to deal with and then deleting the old ones. Now, we also have to one-hot encode the categorical columns. So here's the reason behind this. Computers and models, and these models do not like string values. So for example, sex, male and female. The computer does not like string values. So we need to replace those with numbers. So one way could be to replace male with 1 and female with 2, or male with 1 and female with 0. Or you can one-hot encode them, which means separate it into 2 columns, sex male and sex female, where sex male would be 1 and sex female would be 0, for example, for this one, because it's male. Let me show that in action. So it actually did something weird here. Well, not weird, but expected. Because it saw that the sex was either female or male, it looked at it and said, okay, this is a binary value, so we're only going to put 0 and 1. But for CS and Q, it created the different columns for it, as well as for figure port 1, 2, 3, and 4, which are these. Any questions about one-hot encoding?
So why would you want a one-hot instead of just keeping it like one column? What are some of the benefits?
One of the reasons I've heard is because you don't want to later in the process, because if, let's say you wanted to do, instead of port 1, port 2, 3, 4, you do 1, 2, 3, 4. You later have to basically decode what those numbers mean. And if you have them in the column here, you don't really have to guess like that. Does that make sense? So let's say
I think so.
So let's say I change the S, C, and Q here to like 1, 2, 3. Later in the process, if let's say I made the model and everything, and I predict some values. If I want to know where they embarked, or what embarked value has the most people surviving from, or, well, that's a bad example. But if I want to know where the person embarked from, I need to decode from like 1, 2, 3 to S, C, and Q. But if you have it one-hot encoded, you already know off the bat. That's just one reason.
Yeah, that makes sense.
Another reason is to keep the values low, between 0 and 1. Because if you do 1, 2, 3, 4, it's more variance than 0, 0, and 1. So it can put more importance on those columns, even though it doesn't really have that much importance if you do 1, 2, 3, or 4 instead of 0 and 1. Those are the reasons I know. And here he's doing a heat map of the correlation between every column. So the diagonal, this is the column passenger ID with passenger ID, so it's with the same columns. And this entire thing is mirrored. So what's on this side is all on this side as well. So you can just look at one side. And you can see what has the highest correlation. And you can see, at least from at a glance, that sex male and prefix Mr. has the highest correlation. So these are the most similar. And then you can get the shape of the data with dftrain.shape. Now let's get to actually splitting up the data. You want to drop the survived and passenger ID from the training column. And you want to have it separate, the labels as they're called. Then he basically turned it into a NumPy array by doing dot values. And he basically did that for train and test. And for feature scanning, this is used for numerical values. So for categorical values, we had one-hot encoding. For numerical values, we have scaling, which means that we're basically just compressing the numbers into the same range. The computers, they do not like numbers that are too far apart. So if the standard deviation is very high, it's going to lead to a lot of bias and incorrect results. So we scale them down. Right? This was just me trying to make sure I was doing stuff right. But if you want to see the X train, I'll show you. Because it's not a data frame anymore, it doesn't have a dot head. So it's just numbers. Right, and now we're going into the model. So in the first developer community meeting, I said I was going to be using TensorFlow. In the original notebook, he was using a lot more models, but I just focused in on the TensorFlow model. The TensorFlow model we're going to be using is a sequential model. It's going to be a neural network. And the optimizer for it is going to be stochastic gradient descent. And he explains a bit of how it works. And here it is, the code. So to start, you initiate the class sequential, and you basically add the first layer, which is going to be a dense. It is like this for neural network specifically. The activation is the activation of the weight, how it's gonna initialize as the input dimension, and the kernel initializer. This is just you don't need to include this, but this is just to make sure that the weights are uniform. You add the dropout layer. The dropout layer, as he said, to prevent overfitting. What it does is that it basically drops connections that are created over time to basically keep the neural network generalized instead of overfit. Add a new layer. You can add as many layers as you want, but it might take longer to train. Another dropout layer, and then at the end is really important because we're doing binary classification. It's one output, and you need an activation to be sigmoid, so it can be either 0 or 1. And then you get your model summary. Basically shows everything. I did not import that. So now he's creating the stochastic gradient descent optimizer. LR, that's a learning rate. Momentum, that's another value you can put into this to basically, it's a different form of stochastic gradient descent. I can't explain it all at the moment, but you don't have to have this. You can just have learning rate. You compile the model. You basically initialize the model so that it's ready to train. You want to do binary cross entropy, so it goes into either 0 or 1. And for metrics, you want accuracy. Remember, this is what the competition needs us to optimize. This is a metric that we need to optimize. But there's also other optimizers that can do this. And now we fit it. And fit is basically just another word for training. You pass in your training features, the training labels, batch size. Usually this just so I don't know. It's a lot of things that I can't explain in a short amount of time, but This is just so that every row in the table doesn't have as big of an impact. So it's going every 60 rows, it changes the weights based on calculations it makes on those 60 rows instead of every row. So if I wanted it to be every 30 rows, I could just put 30 rows. Every 30 rows changes the weights according to your calculations. I'll just leave it at 60. Epochs is a number of times you want it to train. And verbose 2, this is just so it outputs the numbers. Now you can predict on the testing set. You can get your gender submission or sample submission, and basically just put in your predictions, output your own CSV, which is going to be your submission, and submit it to the competition. Yep. And that's it in terms of model training and stuff. You can also evaluate it here. There's also this validation area. This is just to make sure that you didn't overfit your model. This is a sanity check, but it's usually done while you're training it as well. The validation set, this is just a part of the training set that you pass into your fit just to make sure that's not overfitting to the training set. Because if it's overfit to the training set, it's not going to do well with data that isn't part of the training set. Right. So as you can see, it's doing pretty good. Accuracy is pretty decent. You could probably end it right here around 60 or 30. This is when it's doing the best. I think we did 30, right? Yeah. You probably saw that and went back and fixed it. Here you can see the loss for a training and test. And he predicted as well, again. Right, and now that you have your model, you submitted it, now it's time to deploy it. So 2 things that you need to do. You need to save your model. Since we're using TensorFlow, you can just put model or variable name .save and the model name. And then for the standard scalar, for classes like this that you use to transform your data, you need to save it as well, so that when you put in new data, you can use these transformers you used on that data as well. So we're going to dump the standard scalar into a pickle, and a pickle is basically a way of storing Python code in serialized form. And you can load this in another Python program. Right. So let me show you what I cooked up. So I said at the beginning of the developer community meetings on the first one that I was going to be using Streamlit to deploy the model. So it's pretty easy. It's using Markdown to create the front end, and in the back end, you can just have another file that loads in your model. So let me go over the back end first. you get the current path with the OS library. You can load in your model using TensorFlow, Keras models, import load model. This is what you would get from the save model. And then you also need to get your pickle of the standard scalar. Then for this function, this is just to predict this is like your row in your data frame that you're going to predict on. I initialize the data frame, and based on what I get from the user, I change that data frame. I'm gonna send this later so you can go over it in more detail. And then I basically just return the prediction. Predict on that data set, or that row of that data frame. I round. I don't know why, but I was having a problem that it was rounding down to 0, even though it was at like 99, which is basically a 1. So I had to do this mp.around, and I returned that value. So for the front end, it's basically markdown. This is like an H1 tag, Titanic Survival Predictor app. Oops, I'm not going to do that. You use the st.write to basically do the dynamic HTML, or markdown in this case. Sidebar, this is just like a bar on the side, menu on the side where you can put in your data. This is a title. And here I'm just adding different inputs that you can do in the sidebar. I'll show you this in actual action later. So based on that data that I get from the user, I pass it into the predict survival function that I just showed you, and I get the survival, whether it survived or not. And if they survived, I write something like this. And if they didn't, I write they did not survive. So there's two ways. Well, when you're actually testing this, you use Streamlit run and the title of the main file that you're using, and it opens up in your browser and you can go from there. But once you've done that and you're finished writing your code and everything, you can actually just deploy it using streamlit.share. And this is what it looks like. I'll put this in chat. I did use a sigmoid, but I don't know why, but it was getting a float, not 1 or 0. And I didn't know why, to be honest. Right, so this is what it looks like at first. You can refresh. This is live. And what you have to do to do this, you basically just make a public GitHub repository. You pass it to Streamlit, and it does the deploying for you. So right now, I'm here. Here's my options to put in data. Right now, it says I will survive. That's because I have the title as Miss. But if I change it to Mr., it'll change to will not survive. So let me put my data in. So this my young adult, or let me put student. Family size 4, passenger class. I'll just put 1 because that's the most common one. Put cheap. And these are some of Queenstown. And apparently I will not survive. So you can go ahead, play around with it. I'm gonna send the GitHub repository as well as the Kaggle notebook in the chat later. And that's pretty much it. Any questions?